Now we are taking up the third type of chemical reaction, that is the displacement reaction. So as the name suggests that in this reaction a displacement will be occurring. Displace means change in place of elements, right. So before we take up the displacement reaction, you need to be familiar with the reactivity series, what actually that reactivity series is. So reactivity series is just the arrangement of elements according to their reactivities. It is just the arrangement of elements in the decreasing order of reactivities, that means more reactive at top and less reactive at bottom. So I am just writing the reactivity series for you, and you need to remember this series because you won't be provided with this series in the chapter. You have to remember it so that on the basis of it you will be able to do the displacement reactions, right. So reactivity series of metals is this. Just look at the board carefully. It is separated by a non-metal. So sometimes you get a question, name a metal, name an element which separates more reactive metals with less reactive elements. Is that a hydrogen? And after that we have the elements which are less reactive than this thing hydrogen. They possess very less reactivity, that is so I'll just, because I've written the symbols, so I'll just make you understand that what this symbol denotes, as you already know, but still to make more clear, I'm just recalling the names. See, it is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin and lead, and this is the hydrogen which is used to separate the more reactive elements from the less reactive elements. Under this hydrogen we have copper, mercury, silver, gold, platinum. You need to remember this reactivity series. See, we have different you can have the different method, your own method, you can frame your own method to remember this reactivity series, but in most of the classes or in the most of the in schools, you can say the line which they are using, they are just learning this reactivity series in the form of song. It sounds to be a funny, but still you can I think it can help you in learning, because when I was young I learned in the same way as my teacher told me. So I am just recalling a musical note to you so that it can help you in recalling this reactivity series. So what is that? It is Kedarnath ka mali आलू ज़रा फीके से पकाता है. Then copper, mercury, silver, gold and platinum. So you can frame your own song to remember this reactivity series. I've told you my song that my teacher told me to how to remember it. So just you can frame a similar method to just recall this series, because this reactivity series plays a very important role, because the element which is placed above is more reactive than the element which is placed down, and for the displacement reaction to be happen, so it can happen only at the cost when the more reactive element react with less reactive element, because from this reactivity series we conclude that more reactive element can more reactive metal or element, whatever you can say, because it happens for non-metal also, in case of non-metals also. So because I have written the series for metals, so just write, there is a method, there is a conclusion made on the basis of this reactivity series, is that more reactive metal can displace less reactive metal from its solution, right. So this reactivity series help in formulating this conclusion that more reactive metal can displace the less reactive metal from its solution. Now just look at the board carefully how we are using this reactivity series in case of the displacement reaction. So first of all, I will be writing a general equation involved in displacement reaction. See, it is a reaction between an element and a compound, right. Means this reaction will occur only when there is an element and when there is a compound, right. This element, if I am talking about metal displacement, then this element has to be metal, and similarly we know that in any compound the first letter, if it is an ionic bond, then the first letter which is used is a metal, right. for the reaction to happen, what has to be there, what you can say that what criteria it should fulfill. The criteria behind that, the metal which is present in an elemental state has to be more reactive as compared to the element which is present in this compound form. So, if this criteria is fulfilled, then only the reaction is going to happen. Otherwise, if the metal which is occurring in the elemental state is the, you can say, the less reactive metal, and the element which is occurring in the compound state is more reactive, then the reaction is not going to happen. Right. So, it will happen only when the metal which is the element which is used, the metal which is used in the elemental state is more reactive than the metal which is present in a compound. Right. Then what is going to happen if this criteria is fulfilled, then only this A is going to displace B, and as a result it will form AC and B will be displaced and will turn out to be in elemental state. So, this is actually a displacement reaction. So, where does this reactivity series plays a role? See, look at the board. So, by reactivity series we came to conclusion that yeah, this is more reactive and this is less reactive. So, this actually lay the foundation of the displacement reaction, because we know that more reactive metal can displace the less reactive metal from its compound. Otherwise, if it is the vice versa, the reaction will not happen. So, this is the general body of the reaction, and one more thing you have to keep in mind, the displacement reaction will strictly occur when it is a reaction between an element and a compound. It cannot occur between two elements, it cannot occur between two compounds. There has to be an element and there has to be a compound, and the most important criteria, the metal, the element which is present in an elemental state should be more reactive than the element which is present in a compound. So that they can displace, more reactive can displace the less reactive. If it is vice versa, the reaction will not happen. Right. So, displacement reaction, coming to the bookish term which you will be getting across in your books, it is that the displacement reaction is a reaction between element and a compound. I am repeating, displacement reaction is a reaction between element and compound in which the more reactive element displaces the less reactive element from its compound. So, as a result we get this, right. I am formulating an example for you to show the metal displacements. See, Zn plus CuSO4, example 1, that is I am taking, this is zinc and this is copper sulfate. What happens? See, it is a metal, again it is a metal. For the reaction to occur, this zinc should be more reactive and copper should be less reactive. Now, from where we will be going to learn that it is more reactive or it is less reactive, we will be considering the reactivity series. So, let us come here and see, we have two metals, zinc and copper. So, zinc lies here and copper lies here. That means the zinc is more reactive, it can displace copper, but likewise the copper cannot displace zinc. So, as we can see, the zinc is more reactive metal is present in the elemental state, so that means it can easily displace copper. Now, that means the copper will be displaced by zinc and zinc will be combining with the sulfate. Now, how you will formulate the molecular formula, this we will be doing in language of chemistry in detail, but for this moment I am telling you that how I am just combining zinc and sulfate. So, just look at here, I am just writing the valencies. This you have to recall, it will not be given in the paper. So, just writing and just crisscrossing, I get ZnSO4. So, I know that this will displace, so obviously it is going to react with this. So, it will form ZnSO4 and plus Cu. So, this is how I am going to tell, to reveal how the displacement reaction has taken place. So, this example I took was entirely on the metals, showing the more reactive metal and the less reactive metal. We can have the displacement reaction for the non-metals also. More reactive non-metal can displace the less reactive non-metal as well. Look at the board. See, it is Cl2 plus KBr. So, this is the second example we are doing. So, what is happening? Cl is more reactive as compared to bromine. As we know that there is an order fluorine, chlorine, bromine and iodine. So, that means chlorine comes above and bromine comes lower. So, that means chlorine is more electronegative as compared to bromine. So, that means it can easily displace bromine, and the reaction which is going to take place is it is going to displace Br and it will be forming this. So this is a kind of displacement reaction. So that means we conclude that the displacement reactions can happen between two metals also. There can be a metal-metal displacement, there can be a non-metal displacement. The criteria behind the displacement is just the more reactive element, it can displace the less reactive element which is present in a compound form. Right. So this is the displacement reaction which we did, and this is the third type of chemical reaction. The first we did combination, second we did decomposition, and the third is displacement. Now we are taking up the fourth type of reaction, that is the decomposition reaction.